While the headlines focus on trillion-dollar giants and the cutting-edge 3-nanometer frontier, a quiet revolution is brewing in the laboratories of Shanghai. A group of engineers armed with outdated tools but brilliant minds has just sent a shockwave through Silicon Valley. They haven't just built a chip. They've built a message. In the age of artificial intelligence, elegance of design might just be more powerful than the brute force of manufacturing. Are we witnessing the birth of a parallel technological universe? Let us dive deep into the story of the unexpected breakthrough that is rewriting the rules of the AI war. For years, the narrative surrounding the global AI race was written in stone. If you didn't have access to the most advanced lithography machines from the Netherlands or the most sophisticated fabs in Taiwan, you were essentially a footnote in history. Export restrictions were designed to be a hard ceiling, a glass roof that would keep the rising tech powers of the East perpetually 2 steps behind. But in late 2023 and throughout 2024, the tech world woke up to a startling reality. A Chinese lab operating under the shadow of these very restrictions announced an advanced AI chip that shouldn't by conventional logic exist. It wasn't just a prototype. It was a functional, high-performance piece of silicon that signaled the rise of an alternative hardware ecosystem. This wasn't built under the privilege of global trade. It was forged under the constraint of geopolitical isolation. When you back a group of world-class engineers into a corner, they don't stop building, they start innovating in ways the privileged never had to. To understand the magnitude of this achievement, we have to look at the David versus Goliath nature of the hardware world. Nvidia's A100 is the gold standard, the engine that powers ChatGPT and the world's most advanced neural networks. It is a masterpiece of modern engineering built on incredibly tiny, highly advanced transistors. The Chinese startup in our story faced the technological equivalent of racing a Ferrari with an old Civic. They didn't have the 5-nanometer or 3-nanometer nodes that Nvidia enjoys. They were forced to use older, more mature manufacturing technology, the kind of stuff we used for smartphones 5 years ago. Yet their bold claim was enough to make investors' jaws drop. Their chip reportedly surpasses the Nvidia A100 in both raw speed and energy efficiency. How do you win a race when your engine is technically obsolete? You don't win by copying the leader. You win by changing the game entirely. There's a long-standing law in engineering. Smaller is better. Older fabrication nodes are supposed to be slower, hotter, and less efficient. This is the paradox of older technology. If you're using 12-nanometer or 28-nanometer tech, you're supposed to lose to the 5-nanometer giants every single time. But the Chinese startup's claims force us to ask an uncomfortable question. Have we become too reliant on shrinking things? When you have the luxury of cutting-edge manufacturing, you can afford to be a bit sloppy with your design. You can just throw more transistors at the problem. But when you are forced to work with less, you have to be smarter. This company didn't find a shortcut in physics. They found a shortcut in logic. They realized that if you can't make the transistors smaller, you have to make the way they talk to each other 10 times more efficient. The secret weapon in this silicon rebellion is a concept called domain-specific architecture. Think of an Nvidia GPU like an Olympic decathlete. It's amazing it can run, jump, throw, and swim. It can render a video game, edit a movie, and train an AI model. But because it can do everything, it carries baggage. It has parts of its brain dedicated to things an AI model doesn't care about, like drawing pixels or handling complex 3D lighting. The Chinese chip is different. It is like a pure Olympic sprinter. It can't swim, it can't throw a javelin, and it certainly can't render Call of Duty, but in a 100-meter dash, which is exactly what AI workloads are, it is unbeatable. By cutting away every unnecessary function, the designers created a lean and mean machine. They exchanged the Swiss Army knife approach for a laser-guided scalpel, allowing them to outperform the all-around athlete in the one race that matters most. Who are the people crazy enough to challenge the global status quo? The leadership team isn't composed of amateurs. They bring a deep Silicon Valley pedigree. In fact, some of them were the original architects behind Google's TPU tensor processing unit systems. These are the people who helped Google break away from Nvidia years ago to build their own internal AI hardware. This is a crucial detail. This project isn't an imitation of Western tech. It's a continuation of a specific lineage of expertise. These founders took the lessons they learned at the heart of the American tech empire and redirected them toward domestic innovation in China. They didn't just bring back blueprints. They brought back a philosophy of architecture that prioritizes how data flows over how many transistors you can cram onto a plate. In the high-stakes world of geopolitics, intellectual property is a battlefield. Most chip companies rely on a complex web of foreign license, ARM from the UK, specialized software from the US, or manufacturing tools from Europe. But this startup has doubled down on a strategy of absolute architectural self-reliance. They claim no foreign IP and no external licenses. This is more than just an engineering goal. It's a national security strategy. By building their own foundation from the ground up, they are insulating their technology from the threat of future sanctions. They aren't just building a chip for profit. They are building a fortress of technological sovereignty, ensuring that no matter what happens in the halls of Washington or Brussels, their AI development won't hit a kill switch. Let's get technical for a moment, but keep it simple. Why is this chip so fast? Most chips waste a huge amount of energy moving data from the brain, the processor, to the closet, the memory. This is called the memory wall. The Chinese chip reportedly removes all the distractions, the graphics functions and non-AI components, and focuses entirely on tensor and matrix operations, the math of AI. But the genius move was in the memory. Instead of using incredibly expensive, hard-to-get high-bandwidth memory, HBM, they used simpler memory but paired it with massive on-chip buffers. Imagine having a massive desk where everything you need is within arm's reach, instead of having a small desk and having to run to the basement every 5 minutes to get a new file. By prioritizing data locality, they achieved high speeds without the high-cost components. Some might argue, why focus on the Nvidia A100? Isn't Nvidia already shipping the H100 and the Blackwell chips? While that's true in the West, the context in the East is different. Export restrictions have effectively frozen the available technology for many Chinese organizations at the A100 performance tier. For a Chinese data center, an H100 is a unicorn, it's mythical and unattainable. Therefore, a domestic, cost-efficient A100 class alternative isn't just a budget option. It is the most practical and vital tool in their arsenal. If you can provide a reliable, locally made version of the world's most popular AI workhorse, you haven't just competed. You've captured the market. Raw performance is great for headlines, but in the real world of data centers, two things rule supreme: dollars and watts. Global-scale GPUs are incredibly thirsty for power and can cost tens of thousands of dollars per unit. For many companies, the bottleneck isn't how fast the chip is, but how much the electricity bill will be, and how many units they can fit in a single rack without blowing a fuse. This is where energy-efficient chips become incredibly attractive. If the Chinese chip can do the same work as an A100 while using significantly less power, it changes the economics of AI. It allows for AI at the edge or in smaller data centers where electrical capacity, not just raw compute, is the limiting factor. The most exciting part of this story isn't the hardware itself. It's what happens after the hardware is plugged in. Much like the early generations of Google's TPU, these chips are designed to improve through software optimization. In the world of AI, the relationship between the chip and the code is a marriage. Over time, as programmers learn the specific quirks of this new architecture, they can write code that runs even faster. This means the chip you buy today might be 20% faster next year just because the software got smarter. This improvement trajectory suggests that the gap between this alternative ecosystem and the global leaders might close much faster than people realize. One chip does not make a revolution. To truly challenge the status quo, you need an ecosystem. The startup isn't just selling silicon. They are introducing large-scale clusters and domestic deployment infrastructure. They are building the racks, the interconnects, the cables that let chips talk to each other, and the software libraries that developers need to build their apps. This transition from single-chip success to a broad ecosystem is the most dangerous development for competitors. It signals that China is no longer just looking for a workaround for sanctions. They are building a completely independent second lane for the future of humanity's intelligence. We have to look at this through the lens of the Great Tech Divide. In a world defined by sanctions, supply restrictions, and trade retaliation, domestic chip design has moved from a business goal to a matter of resilience. This effort is part of a wider technological sovereignty strategy. It is about ensuring that if the global internet or global supply chain ever fractures completely, one side isn't left in the dark ages. This chip is a survival kit for the digital age. It represents the realization that in the 21st century, the most important resource isn't oil or gold, it's the ability to process information. History tells us that we've seen this movie before. In the 1970s, people laughed at Japanese cars. In the 1990s, people laughed at Korean electronics. The pattern is always the same. First, you copy. Then, you match the previous generation. Then, you innovate under constraint. And finally, you lead. The Silicon Rebellion is currently in the innovate under constraint phase. History suggests that once a country can match yesterday's standards using yesterday's tools, the jump to tomorrow's standards is inevitable. The question is no longer, is it possible? The question is, how quickly will the gap close? Finally, we see the ultimate sign of belief in this project. The move toward an IPO, initial public offering. By preparing to go public, the company is signaling to the world that they believe in the commercial durability of their approach. They aren't a flash in the pan or a government-subsidized hobby. They are a business with a viable path forward. This marks the beginning of a parallel AI chip ecosystem. In the future, we may have two distinct paths for AI, the high-complexity, high-cost path of the West, and the high-efficiency, purpose-built path of the East. Both will thrive, but the competition between them will accelerate the progress of AI for all of us. What can we learn from this story and apply to our own lives? Constraints are a catalyst. When you feel like you don't have the best tools or enough resources, remember that the world's most advanced chip was built using outdated technology. Use your limitations to force yourself to think more creatively. Specialization is your superpower. Don't try to be everything to everyone. Like the AI chip that cut away the graphics to be a better math processor, find your one thing and become world-class at it. Build your own foundation. Don't rely entirely on licenses or the permission of others for your success. Develop your own skills and your own intellectual property so that you are resilient in the face of change. I hope this story of the Silicon Rebellion has inspired you to look at your own challenges in a new light. Thank you for joining me on this deep dive into the future of technology. I wish you all great health, a clear vision, and the courage to build your own path. If you enjoyed this long-form narrative, please don't forget to subscribe to the channel, hit the notification bell, and share this story with someone who loves tech as much as you do. Your support helps us keep telling these incredible stories.